nothing works in the cell because if the instructions for all the basic steps are missing, no work can be done. The aforementioned power plants of the cells, the mitochondria, are also very important for the cell. These provide the cell with enough energy to perform all its tasks successfully. In your factory, the mitochondria might be the snacks and packed lunches for the employees or the energy for machines in the form of electricity. The endoplasmic reticulum, which forms proteins and passes them to the Golgi apparatus so that they can either be released from the cell or incorporated into the cell itself, also becomes important in the course of the process. The two organelles together are therefore almost like a small post station that either passes on products developed in the factory to other factories that need the products or distributes the products in its own factory to support departments or carry out further work steps. When talking about autophagy, however, you must not forget the lysosomes, which break down unnecessary substances so that the resulting raw materials can then be reused. However, the lysosomes can not only break down the cell's own substances, but also absorb substances from the environment and recycle them, or in the case of toxic substances or attackers such as bacteria or viruses, destroy them and break them down into their individual parts. In your factory, a system like this would certainly also be an advantage, as you would not have to buy everything new. You could save raw materials and money and even protect your factory from attackers and hackers. To summarize once again, remember that the cell nucleus provides the information, the mitochondria provide the energy, the endoplasmic reticulum and the Golgi apparatus together serve as the mail and distribute products and information from the cell nucleus within the cell or to the outside. And the lysosomes are the eco-freaks who do not want to throw away any raw material without first checking that it is really no longer usable. All organelles are closely connected to each other, and as soon as one part no longer functions and cannot be repaired, the whole cell is destroyed. But wait, before you continue listening, you need to know about a very important part of the cells that forms the basis for all metabolic processes, because without a cell wall that shields the cell from its environment, none of this would be possible. In your factory, you also need a few walls, doors, and windows so that not just anyone can come into the factory and take what they need. You also need to protect your factory from environmental influences such as rain, snow, heat, or even a storm or flood. And you certainly don't want your products to simply spread uncontrollably throughout the area and end up with nothing left. The same applies to the cells because they don't want anything to be stolen from them, to be damaged by environmental conditions, or for the laboriously produced cell products to be distributed without having a function. Each cell has therefore developed a small wall that protects it from all these things. If the cell region is flooded with nutrients, for example, the cell can protect itself from this and decide for itself via channels in its wall how much it wants to let through or not. This also applies to transport out of the cell, as cells can also produce things that they do not need themselves, but are only needed in other areas. If the cell then wants to release something to the outside, it can open its channels and export the desired substances. You can imagine it all as a huge organism that is divided into many small units. If the organism provides substances, each unit can decide for itself whether it needs the substance or not. And if the organism notices that something is missing in one part of it, it can even make other parts aware of this and ask the units to support each other. Isn't it incredible how much these little cells can do? Wouldn't that be an example that the global economy could take a leaf out of its book? The DHL of cells. Now that you have already learned a lot about cells and have refreshed your knowledge a little, you can delve deeper into the topic and look at metabolism and transport in the cell. As you can perhaps imagine, the cell cannot produce all the products it needs itself, but must also absorb things from the environment and incorporate them into the cell. After all, a factory cannot function without a constant exchange with the environment in the form of imports and exports. New raw materials are constantly being delivered and finished products shipped, and this is exactly how it works in the cell. There are many different types of transportation which you can take a closer look at below. First of all, the uptake into the cell, endocytosis, which can be further subdivided into pinocytosis and phagocytosis. These terms probably sound very complex to you at first, and you are wondering how you are supposed to understand all this. But don't worry, the whole thing is simpler than it sounds, and you only need a brief overview of the individual types of transport. The difference between the two types of uptake really only lies in the type of substance that is absorbed. Pinocytosis involves soluble products and phagocytosis